So now this video is for those that are actually in secondary school. So how can you be able to sketch the graph of the quadratic functions? And let's say we have the quadratic function given as y is equal to x squared, should be ax squared plus bx and plus c. This is the general form of the quadratic actually function. And how can you be able to sketch the graph of the quadratic function? And rather, what are the actually necessary information and we should have to keep in mind whenever we are sketching the graph of the quadratic equations, rather the quadratic functions. So now what we need is we need to have the actually x-intercepts. So we should need to have the x-intercepts. So we need to have the x-intercepts. And how should we have the x-intercepts? X-intercepts will be obtained upon solving the actual equation. So that will be obtained upon solving the equation. And we should also need to have actually the y-intercept. So we need to have the y-intercept. That is, we need to have the y-intercept in order to also be able to sketch the graph of the quadratic actual function. And we also need to have what we call the vertex. So we need to have what we call the vertex. So should be the vertex. So a vertex, these are the coordinates at the turning point. Mind you, the graphs of the quadratic equation actually functions actually possess the parabolic curve, hence they made concave upwards or downwards. So we should have to understand about the vertex. So a vertex consists with two coordinates, h as well as the k, where h corresponds to the x coordinate and actually k corresponds to the y coordinate. So keep that in mind. So that is corresponds to x and this is corresponds to y. And we should also need to have the concept of actually concavity determinants. So concavity determinants. What is the concavity determinants? So a concavity determinants, it is actually a value that determines whether the graph will concave downwards or upwards. And basically, the value of a determines whether the graph is concave upwards or downwards. If the value of a is negative, it means the graph will concave downwards. Likewise, if the value of a is positive, the graph will concave upwards. So those are some of the things you should have to understand about whenever we are going for the sketch of the quadratic actually functions. Rather, whenever we are sketching the graphs of the quadratic actually functions. Let's say we have a typical quadratic function given as f of x, let's say is equal to x squared and plus x, let's say minus 6. Let's say this is the case. So now how should we be able to sketch the graph of this actually a function? So mind you, we are being told to sketch, not to plot. Otherwise if we would have to plot, then it means we would have used the table values. But now we just have to sketch the graph. So all we need is we need to have the x-intercepts. So we need to have the x-intercepts. That's the first thing to consider. And how should we have the x-intercepts? And those will be obtained upon having the f of x, or say a y being equal to, so mind you, f of x, it is the same as y. So which means we'll have f of x being given as y. So have it as x squared and plus x minus 6 is equal to 0. Then I'll be able to solve for this using the factor method. That will be given as x squared and that plus 2x minus 3x minus 6, that will be equal to 0. And we'll have x in that way, and that plus 2 minus 3 x plus 2, that will be equal to 0. We'll have it as x plus 2 and it times x minus 3, that will be equal to 0. Hence we'll have x is equal to negative 2 and our x is equal to 3. Now we have the x-intercepts in that case. That is x being given as a negative 2 and also x being given as, and that should be a positive 3. So let me just have to transfer this to here. So I'll have them there. Then next we should have the y-intercept, and of which, if we have the general form of the quadratic, actually a function given as y is equal to x squared plus bx plus c. The value of c itself corresponds to the y-intercept. Hence, the y-intercept of the function, it is given as the negative 6. So the y-intercept is given as the negative 6. So that is all for that. And we should have what you call the vertex. Now, how should you have the vertex? A vertex consists with actually two coordinates, that is x as well as the y, and these coordinates are corresponds to h as well as the y. Should be h as well as the k, where this is x and this is the y. Now, how should you have these values? First thing, we should have to calculate the value of h. And how do you find the value of h, which is the y actually x coordinate, the turning point or the vertex? We have it as negative b over 2a. This is the formula. And in this case, we have a being given as 1 and b is given as 1. So in that case, we'll have it as negative 1 divided by, and that should be 2. That is the same as 0.5. Of course, in that case. So which means h is given as 0.5. Now we have h, that is given as 0.5 or 1.5, actually 1.1 divided by 2 in that way. Then now we need to have the value of actually a k. So the value of k, it is the same as having f of actually f of h, where in the function where there is x, are going to substitute with the actually h. So now have it as 0.5 to the power 2, the plus 0.5, and we'll have it as minus 6. Then we'll have 0.5 to the power 2, should be 0.5 to the power 2, and that should be now we'll have it as, that is 0.25. Then plus 0.5 minus 6. What would be that? So plus 0.5, that is then minus 6. Then we'll have it as negative 5.25. Now that is the value of actually a k, or the y coordinate at the turning point. So k is given as negative 5.25. So keep that in mind. And also on the same case, Since the value of a is actually a positive, in this case the value of a is positive, it means the graph is to concave upwards, so the graph will concave up. So those are the actually necessary information that we need to have before actually we sketch the graph of the quadratic equation. It should be a quadratic function. Then I'll come up with the Cartesian plane. In your case, you may have a graph paper that you are always being provided, or else you are provided this actually a page where you have to highlight everything. Let's say that is the case. Then you have to give a typical scale. In this case, we may think of having, let's say, 2, 4, let's say 6, 8, and the -2, -4, let's say -6. We should have that in that way. And in this case, we can also have it as, let's say, 2, let's say 4, let's say -2, let's say this is -2, let's say this is the -4, like that, and let's say this is -6. Let's say that is the case. Then we should have to highlight what is the actually a turning point. Now first of all, just have to highlight what are the actually x intercepts. So -2 and +3. Let's say this is the -2, and let's say this is the +3. Then we have the y-intercept, which is -6, which is this point in that way. Then we need to have the turning point, which is 0.5, -5.2. 0.5, that is somewhere here, can be that, and -5.25, that can be somewhere here. So which means this is the actually a turning point. So in that case, what it tells is that it means the graph is going like this, and should be. So in this case, of course, because of the issues of a space, that's why it seems like, but let me just have it in this way. And let me just have to take out some stuff. See, let's say this is the case, and I'll have the typical Cartesian plane, and let's say being given as this. And I'll have it in this way. Let's say this is, let's say should be 2, 4, let's say 6, 8. This is -2, -4, let's say -6. We have 2, 4, let's say a 6. We have -2, let's say this is let's say -4, and let's say this is -6. Let's have it in that way. Then the first thing, we should have to highlight the x actually intercepts, that is -2, and we should have a +3 here. The next, we should have the turning point, that is 0.5. Of course, it's somewhere here, because if this can be given as 1, then 0.5, it is somewhere here. And we have the y actually coordinate, that is -5.25. So 5.25 can be somewhere. Let's say this is 5, then 5.25 can be somewhere here. Let's say can be somewhere here, so which means this is the point of interest. That's the turning point in that case. Then now if this is the case, then what is the y-intercept? Now the y-intercept is given as the negative actually 6. So then the graph will go like this. Then the graph will go like this. So that will be given as that. So this is the graph of our interest in that case. So first thing, we should have to understand how to come up with the actually x-intercepts. Then we should have the corners of the turning point. Then we should have the y-intercept, as well as to determine whether the graph will concave upwards or not. So the value of a, the nature of the value of a, determine whether the graph is concave upwards or downwards. No matter how big or small the value has to be, but if it is positive or negative, then that's enough information to determine whether the graph will concave upwards or downwards. Even if we can have the value of a being given as 2000, much as it is much as the value of a is positive, it means the graph will concave upwards, and if it is negative, it means the graph will concave downwards. Let's say we have this case. Let's say we have y is equal to, should be x squared, and minus, let's say, x plus, let's say, 12. Now how should you have to sketch the graph of this function? Principle remains the same. We should have first of all the x-intercepts. Now in this case, it remains to have it as x squared minus x and plus 12 is equal to 0. X-intercepts are calculated upon having y equal to 0. So we'll use the factor method, and that will be given as, of course, here we should have a negative as well. Here we should also have the negative as well in this way. Like that. So now we'll have it as x squared and plus, and that should be 3x, and the minus should be 4x minus 12, that will be equal to 0. You have x and plus 3 minus 4, the x plus 3, that will be equal to 0. You have x plus 3 and that times x minus 4, that will be equal to 0. Hence we have x is equal to negative 3 and x will be given as the 4. So those are the actually x-intercepts you should have to get it up to. Now the x-intercepts are given as x being given as negative 3 and x is equal to 4. The next we need to have the y-intercept. And the y-intercept is calculated upon having x being given as a 0, of which the y-intercept is given as the same. That is given as the negative 12. Even if we think of having x 0, 0, we'll have it in the same way. So have it negative 12. Then we know that the value of a is positive, hence the graph is concave upwards. So that is the information you should have to know as well. And what next? We should have to calculate the vertex. So we need to have the value of h, that will be given as negative b over 2a rather. So what is the b? We have it as a negative 1, and with that negative will be given as the positive 1, and that divide by, we have it as 2, actually 2 times a, that is given as 2. Then we have it as 0.5 as the actually x coordinate at the turning point. Then how should you have k? So now the k will be given as 0.5 to the power 2 and the minus 0.5 minus 12. And in that case we'll have it as 0.25 minus, now have it as 12.5. in that way. So 12 point should be 5 minus 0.25, of course. That is negative 12 point, so negative 12.25. That is the value of actually k at the turning point. So let me have them here. We have h, that is given as 0.5, and we have a k that is given as negative 12.25. So we have that in that way. Then now we have the full information that will help us to sketch the graph of this actually a function. Now we have the Cartesian plane using the same principle. In this case we have it as, let's say, actually 2, 4, 6, 8, and let's say we have 10, and negative 2, negative 4, negative 6, negative 8, negative 10, we have negative 12, negative 14, because we are going as far as, in this case, this is y coordinate, by the way, at the turning point, so which means along y-axis we need to go somehow far below, because the negative 12, it's something very big. So we just have to be very careful with the way we are giving the scale itself, because it also matters a lot. So we may think of going arbitral up, then I'll have then let's say this is negative 2, let's say negative 4, negative 6, negative 8, negative 10. We just have to be very clear in this way. I should also further transfer that. The second be somewhere here. So now, which means I'll have something like this. Let's say this is negative 2, negative 4, negative 6, negative 8, negative 10, negative 12, and let's say negative 14 that way. Then I may have 2, let's say this is 4, so should be that. Then let's think of highlighting the actually x-intercepts. We have negative 3, and that is to be somewhere here. And we have positive 4, that is somewhere here. Then I will have to highlight the actually y-intercept, that is negative 12. We have it here. Then we have the actual turning point. We have 0.5. Let's say this is 1, then it means 0.5 is here. We have negative 12.25. So in this case, it is somewhere here. So which means this is the turning point, of which the graph will go like this. Then we have the turning point, of which the graph will go like that, of which you need to have to develop the skills of having a freehand curve, because you'll be required to sketch this actually using the freehand. But anyway, this is the graph of interest, as you can see. So that's how we sketch the graph of the quadratic actually functions. Now let's say we have been given that a certain quadratic equation, quadratic actually function, has got the roots given as x is equal to 5 and also x is equal to, let's say, 4. Now sketch the graph of this actually a function. So now first thing, we should have to use the principle of having the quadratic equation given the roots, and of which you have it as x minus 5, write that times x minus 4, actually x minus 4 is equal to 0, and to have it as x squared and minus 4x minus 5x and plus 20, that is equal to 0. So now which means we'll have it as x squared minus 9x and plus 20 is equal to 0. Now since we are much interested to have it as a function, then it means we'll have it as y is equal to x squared minus 9x plus 20 in that way. So this is the quadratic actually a function corresponding to those actually given roots. Now we have the roots already, we have the x-intercepts already. That now what we need is to have the vertex as well as we have the x-intercepts, and also we have the y-intercept that is given as the positive 10, actually positive 20. Then now what we need is to have the vertex, and also since the value of a is positive, it means the graph is concave upwards. Now we need to have the vertex. The vertex is given as h negative b over 2a. That will be given as we have a negative 9 as b. With this negative, we'll have it as a positive 9. Divide by 2 times a, that is given as 2. So have it as, and that should be, we have it as a 4.5. That is the actually x coordinate at the turning point. Then now we need to have k. How should we have k? Then we'll substitute into the actual function where there is x are going to have h. That will be given as 4.5 to the power 2 minus 9, 4.5 and plus 20. Now what is 4.5 to the power 2? Now 4.5 and that to the power 2, we have it as 20.5.25, and that we have 9 times should be 4.5. We have it as now have minus 40.5 and a plus 20 in that way. Then we have, let's say 20.5 should be 0.25 0.25 and minus, and that should be 40.5. In that case, then the plus, and that should be 20. So we have it as negative 0.25. That is the value of h. Now the vertex, actually a vertex is made up of, that is 4.25 and a comma negative 0.25. That is the vertex you should know. Now we have the full information that we can be able to sketch the graph of this function. Now since the y-intercept is given as 20, Now we'll have now try to come up with a graph of this function on your own. That is. And also, let's say we have been given that the certain quadratic actually a function has got the roots given as x is given as 4 divided by 5, and also x is got, let's say, a 6. So try to come up with a graph of, to sketch the graph of that function in that way. Now, what if we have been given that the graph of the certain quadratic actually a function? The graph of the certain quadratic actually a function has got the roots given as 2 and also given as, let's say, 3. And also the graph consists with, and also given that the graph has got the y-intercept, let's say y-intercept, let's say given as, and that should be, let's say, 8. Now, what is the actually a graph of this actually a function? In other words, we should have to sketch the graph of this function. Now, how should we have it all? Now, first thing, we should have to come up with the function corresponding to this actually information. So I understand you know how to come up with the quadratic function. It should be a quadratic equation given the roots as well as the y-intercept. We are just applying the concept here. So let's start working with the given roots. How should you have the actually a quadratic equation? We'll have it as x minus 2 times x minus 3, that is equal to, of course you can also use the other method where you have b is equal to negative r1 plus r2, and c is given as r1 times r2, where you just have to substitute. That is whenever you are working out with the roots, whenever you are only being working out with the roots. That is x squared minus 3x minus 2x, and the plus 6 is equal to 0. That is given as x squared minus 5x, the plus 6 is equal to 0. Now, the equation that we have is having the y-intercept, that is positive 6, and a contrary from the y-intercept that we have been given. Now, what is the principle behind, if you can remember? So we'll have to multiply this one by a constant, let's say a. We'll have it as ax squared minus 5ax and the plus 6a, which is equal to 0. Then we'll have to equate this one to the given actually the y-intercept. So in this case we'll have it as 6a is equal to 8. That is the same as a is equal to 8 divided by 6. So what is the 8 divided by 6? Then I'll just have to substitute back into the actually equation. Hence we'll have it as 8 divided by 6, and of course that corresponds to have it as, now should be 4 divided by 3. That is the same as that. Hence we'll have it back now we'll have it as, 4 over 3 x squared minus 5 times 4 over 3 x, and the plus 6 times 4 over 3 is equal to 0. We have 4 over 3 x squared minus, now have 20 over 3 x, and the plus, we'll have 3 into 6 given us 2. You have 8 is equal to 0. Now this is the quadratic actually equation of our interest, since we have the y-intercept given as 8 as it was supposed to be. The next to have it as y is equal to 4 over 3 times x squared minus 20 over 3, and the plus 8 is equal to 0. Now should be Now this is the quadratic function, and that corresponds to this information. Now you can be able to have the sketch of actually the graph of this actually equation. Since we should be a function, since we have the we already have the roots, and we just have to calculate, and also y-intercept, we just have to calculate the actually we just have to calculate the we just have to calculate the vertex. And also you have to understand that since the value of a is positive, it means the graph is concave actually upwards. So finish off by looking at the vertex, then try to come up with a sketch of that graph. And let's say we have the certain quadratic equation. Should be a function with roots given as x is equal to -4 and x is equal to, let's say, 1. And assuming that it has got the y-intercept, let's say given as that should be -12. Now what is the graph of this actually a function? So try to have that one actually out. And let's say we have, in this case, let's say we have the quadratic equation should be a quadratic graph. That is in this case. Let's say this is -1, and let's say this is, let's say, 5. And let's say this is should be -2. The point is given as -2. Let's say that's the case. Now how should we have the value of the turning point? In other words, we should have the coordinates at the turning point, and also we should have the axis of line of symmetry. So apply the concept of the axis of line of symmetry we actually discussed about before. Of course, we say the axis of line of symmetry, it is given as x is equal to h, where h is the turning point at the it is the x coordinate at the turning point. So try to have that. And let's say we have, in this case, let's say we have the two quadratic graphs. That are going off like that. Let's say this is, let's say, 1, that is 1, and let's say both are having the y actually intercept there, let's say given as -5, and let's say this is should be 1, and let's say here we have it as, let's say, a 0 in that way. Now find the distance of the line, let's say PQ, if this is the case. So try to have to understand that one. Let's say this one is having the y-intercept given as -3. So try to see how best you can have that. So just a recap, you need to have the x-intercepts in order to sketch the graph of the quadratic actually a function. And also you need to determine whether the graph is concave upwards or downwards. And also you need to have the vertex that consists with h, k, where h is given as -b/2a, and you find k upon substituting to the function with h. And I also need to have the y-intercept. So these are the key things you have to understand whenever you are sketching the graphs of the quadratic actual function. Thank you.